Our next problem is to write a balanced, complete ionic and net ionic equation for each reaction. Okay, so in order to write the complete ionic equation, we must separate the aqueous ionic compounds. Now, the solids do not dissociate in solution since it is soluble, so we do not count those. So let's start off from left to right. So we have Ag plus just aqueous plus our NO3 minus aqueous plus K plus aqueous plus our Cl minus, which is also aqueous, forms. Okay, so this solid does not dissociate, so it simply stays AgCl. Plus, we have our K plus aqueous, and we have our NO3 minus aqueous. So that would be the complete ionic equation. So now for our net ionic equation, we must eliminate the spectator ions, and those are the ions that appear on the left and on the right. So we have Ag plus, that is not on the right, so that stays. NO3 minus is on the left and the right, so those are going to take out. And then our potassium also appears on the left and the right. So we are simply left with Ag plus aqueous plus Cl minus aqueous yields AgCl solid. Our next equation, we're going to do the same thing. The complete ionic equation is going to separate the aqueous ionic compounds, which is not including the solids. So we have Ca2 plus aqueous plus S2 minus aqueous plus Cu2 plus aqueous plus Cl2 minus aqueous, yielding Cus is going to stay as it is since it's a solid, plus our Ca2 plus aqueous and our Cl2 minus aqueous. Okay, so now for our net ionic equation, we're going to eliminate the spectator ions, which appear on the left and on the right. So we have Ca2 plus on the left and on the right. We have our S2 minus just on the left, so that stays. And our Cu2 plus also stays. And then our Cl2 minus will be eliminated. So we are simply left with S2 minus aqueous plus Cu2 plus aqueous yields Cus solid.